Hey guys, welcome back to AlgoYogi. We are now doing graph series and our next problem in the list is count servers that communicate. Let's go to LeetCode and give this problem a read. You are given a map of a server center represented as m cross an integer matrix called grid, where 1 means that on that cell there is a server and 0 means that there is no server, or you can say it's empty. Two servers are said to communicate if they are either on the same row, yes, or same column. All right, so now we need to return the number of servers that communicate with any other server, and that too we have to make sure that we are not basically duplicate counting these servers. So let's consider one example from this. This is the third example, and I think this is the best example to go over. So this is the grid that I've just converted into. This is a visual representation. This one is a visual representation here, and this is the converted grid, which is actually given to us as a list, 2D list. Now, 1 means there is a server, 0 means there is no server. Now, if you see in this graph right here, in this first row, so how many rows are there? There are basically m rows, and here there are 4 rows. So I would write it like this. So I'm gonna 0, 1, 2, 3, these are the columns. So n equals to 4, and then 0, 1, 2, 3. So m equals to also 4. Okay, so this is 4 cross 4. Now there are 2 servers in the first row. There are 1 server in the second row, third row there is 1 server, fourth row there is 1 server. Okay, same goes to this grid. We are doing the same thing. I think we can choose at this point, we can choose to work with either of them. Okay, now how about the first column? First column there is 1 server, second column there are 2 server, third column there are this is 1 server, 2 servers, and there is 1 server. Now how many of these servers are communicating? How do we check? The logic will be really simple. We are going to iterate over this 2D grid. Now, first thing is we count each row, how many servers are in each row and how many servers are in each column. That's the first step. Second step is going to be, we're going to go over each of these basically cells and then ask if this is equal to a server. So let's say this one is equal to a server. Yes, this is. Second check would be, is there any other server other than this? Is there any other server in this particular row? And then I will maintain a count. So I will maintain a count to basically add that. So I'm basically starting right now. So I'm right here. Is there any other server on this? How do we check? We're gonna check if it is, if this row, this particular row, I could call it row or rows, and then I'm gonna enter this I, because that's how you access the row, right? If you had to access the column, then you would be accessing that column through calls with J, if you are using I and J to basically go over this 2D matrix. All right, so you can see, yes, this count is basically, this thing has to be greater than 1. Why? Because this is already, we are only checking whenever we are on a cell that already has a 1. So that means 1 row can have 1 server, but that is not communicating with if there is just 1 server on that particular row, or there is another server on that same row. So 1 cell is part of 1 row, 1 column, and we're going to check if either the row or the column, given that this cell is already a 1, this is a server, either this row or this column have a value that is greater than 1. So this is what I'm talking about, this right here. So either if this is a 1, so either this or this or this, or, so this is an or sign. Okay, I'm just trying to draw the or sign here. So either row or the column, one of them has the value greater than 1, and given that this is already a 1. So let's go over here right again. So either, so this has 2, 1, 1 and 1. This has, these are the columns by the way, 1, 1, 2 and 1. So now we came over here. Is this is a 1, and this has a row that has the value greater than 1, so this counts. So this is one of our servers, then this is another server part of this row. So because this was communicating, then these two we will increment to our count. Then how about the next row? So but this is 0, so we're gonna skip these. How about this one? So this one right here is just 1, so from here it does not qualify to be a server, but this can communicate with the this another server that is in the same column. So here this one actually does qualify. So there are, so we're gonna count this, and increment our count. So this passes. This is also another answer. Skip this, come here. Now this 2 is present in the same column, so we're gonna add one more, and then this is another answer. Skip this. So voila, super simple solution. I know it's a part of a graph problem and we're not really doing any DFS BFS. What we're going to do is two pass. One pass is going to be, so let me just draw this again. So one pass, there are two passes by the way. So we're going to have rows. This is going to be an array basically of m size, and columns will be another array of n size. Now we're going to go over this grid. So what we're going to do is we're going to, at each row or column, we're going to increment. So this is going to be my I. So I will be here, j will be over here, 0, 1, 2, 3, 0, 1, 2, 3. Instead of this, I can just simply write this. And this might be the most detailed answer that I might have explained. So let's have rows 0, rows 1, rows 2, and rows 3. Okay. This is rows. How about column? So column, col 0, cols 2, cols 3, and cols 0, 1, 2 and 3. Okay, these are the two things we care about in my first pass, and then right here as well. Okay. All right. And I think at this point I might be overdoing it. So I'm gonna go over this grid, and I'll check that first row has two servers. Second row has 1, third row has 1, fourth row has 1. This one has 1, this one has 1, this one has 2, this one has 1. Now second pass. In second pass, I will come over here. I'm gonna check if this grid I and j is equals to 1, and either the row at I, if I'm at the 0, either this is basically greater than 1, which is right here, or this is greater than 1. Now we understand completely. I'm not gonna make it more messy. Let's jump into the code directly. I think I might be already overdid it right there, because I think it was super simple already to begin with. So first thing first, I think it's easy that we take out our m and n. So m is the number of rows and n is the number of columns. Len grid, and then len grid 0. So this is the columns. Let's go over it. For I in range, m, which is rows, for j in range, column, which is n. Now I forgot to write, like declare that we need to have rows. Rows would be rows and columns. Let's have them in the same, declared in the same row. So rows and columns, rows would be basically of size n, and then column would be of size, rows would be of size m, and column would be of size n. Awesome. So we are counting rows and columns. So if there is a 1, so if grid I is equals to 1, so that means, not I, that's not how you access the element. You access row and then column. If this is a 1, that means this needs to be added to row and also column. So that means rows I plus equals 1, and calls j, column is at j, okay, is also plus equals to 1. All right, now let's do the second pass. I'm just gonna copy paste, and now if this is again 1, 0 or 1, now it has to be equals to 1. And now let's have our answer. Basically we can call it servers. We're gonna count the servers right now is 0. Copy this. So first thing, this has to be a server. The first the cell that I'm seeing, it has to be a server. What's the second condition? Either the row, so rows I has to be greater than 1, or calls j has to be greater than 1. Super simple. Okay, that's it. If this is the case, then I will increment my server by 1, and then finally I will return my server. Return my servers. Done. Let's zoom out. I'm gonna zoom out and run this now. Run it on the examples. Okay. Weird. What is it? Is it because, okay, int object is not callable? What is not callable? Okay, yeah, this or this and. All right, so those mistakes, they can happen, but please avoid them. I'm stupid, I do them. Oh, I make these mistakes all the time, but that's because I'm stupid. You guys are not, so never do it. Let's submit this, and I think hopefully this will be a nice solution. Yeah, 96, that's pretty good. All right, let's write down the time complexity. Time complexity would be big of m into n, where m is the number of rows and is the number of columns. What about the space complexity? Are we storing anything? Yes, we are. So it's rows and column. Okay, rows and columns. So what we're gonna do is space complexity is going to be big of m into n. No, it's going to be m plus n. Okay, that will decide. It could be either maximum of these. That's how you compute, because we are storing columns separately and rows separately. Okay, they're not part of this one grid. We're not making it one grid. Okay, these are different. All right, so that is it. Remember this, like a lot of people might make mistake here. This m plus n, not m into n. But yeah, time complexity 2 for loops. It is what we have written here. Let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.